Now children, the next part that I want to explain in detail, and basically you'll be asked as a reasoning question in the examination also. Okay, so in the last YouTube video you saw that the relation between Cp and Cb. Okay, and from that relation you saw that Cp is greater than Cb. But the question arises out here is why Cp is greater than Cb? That means the molar specific heat at constant pressure is always greater than molar specific at constant volume. Why? So for this part to understand, so let me take a vessel. So let me take a vessel. Suppose you have a vessel out there. Okay, so this is a vessel. Now this vessel I'll feed with a gas. I'll take a what? Gas. But what type of gas I'll take? Ideal gas. So you have outer what gas? Ideal gas. What? How much mole of ideal gas? 1 mole of ideal gas. For this is for 1. Okay, let me write this way. This is for 1 mole of ideal gas. Now this gas is fitted with a piston, movable piston. This is a movable piston. Okay, this is a movable piston. So suppose a gas is fitted. This gas, that is 1 mole of gas, ideal gas is fitted. Okay, with a piston. Okay, in a vessel. Okay. Now what I do? We can supply the heat. Means we can supply the heat to the gas. So if we supply the heat to the gas, so heat supplied from outside. So when we supply heat to this gas from outside, okay, and we raise the temperature of the gas by say 1 degree Celsius. 1 degree Celsius. And you know 1 degree Celsius rising temperature is also equals to 1 Kelvin rising temperature. So what happened? When the heat is supplied to the gas would expand. So let me just say the gas would expand. Okay, so when gas would expand, it definitely this gas will push the piston upward. When the gas expands in volume, then this gas pushes the piston upward. Okay, but we can maintain the volume of the gas constant. Even the gas would expand in such a way so that I maintain the volume constant. Volume what? Constant. Volume of the gas constant. But how to maintain the volume constant? Even if you are supplying heat to the gas and the piston trying to move upward. So in that case, we place some weight on the piston. We put some weight on the piston. So you are supplying heat to the gas is trying to expand, okay, so that the gas would try to push the piston upward, but in order to maintain the volume of the gas constant, I put some weight over the piston, so that the volume of the gas remain what? Constant. So children, what happened under this case? In this particular case, you will observe that whatever heat you supplied or given to the gas will be totally used in increasing the temperature of the gas. Yes, the temperature is raised by how much? 1 degree Celsius or 1 Kelvin. But the heat given to the gas will be totally used in increasing the gas. So under this case, what happened? This increases the internal energy of the gas. That means the heat supplied to the gas is totally used to increase the internal energy of the gas. Because as I said already, for ideal gas, when the temperature changes, the internal energy of the gas also changes. But no change in the volume. When there is no change in the volume means definitely the work done by the gas is 0. And we have discussed already in details in the relation between Cp and Cb. So when there is volume constant, no work is done by the gas. But under this case, as you know children, the heat that is taken out by the gas, okay, is actually used to raise the temperature of the gas by 1 degree Celsius. And this is the molar specific heat of the gas at constant volume. So as per the definition of molar specific heat at constant volume, is the amount of heat supplied to the heat energy required to raise the temperature of 1 mole of a gas, okay, 1 mole of the gas, okay, through 1 degree Celsius without increasing the volume, means when the volume of the gas remains constant. Now suppose the same gas is now allowed to cool and heated up against to increase the temperature by 1 degree Celsius. Means we take the same gas, now we cool the gas and we again supply heat. After some time again we supply heat to increase the temperature by the same amount, 1 degree Celsius. But this time we do not place any weight. We just replace the weight of the gas. Weight placed on the piston. Okay. So in that case what happened? The volume of the gas will change. But we change, the volume of the gas will change, but we maintain the pressure constant by keeping the pressure what? Constant. So when we keep the pressure constant, so that the volume of the gas will definitely change, so that the temperature of the gas raised by the same amount, 1 degree Celsius or 1 Kelvin, by removing this weight placed on the piston. Then under this case also you will observe the gas would expand. Yes, definitely the expansion of gas takes place. But gas which would expand doing some external work against the what pressure? Against the pressure in pushing the piston upward. Yes, definitely when the gas expand, the piston will push upward. So under this case what happened? The necessary energy for this work will be taken from the heat, because heat is helping to do the work to expand the volume of the gas. But at the same time out here you can see the temperature is rising by 1 degree Celsius. So definitely there is an increase in what energy? The internal energy of the gas. So from here I can say that at constant pressure the gas will take heat not only for raising the temperature of the gas by 1 degree Celsius, but also for doing work against the external pressure. Also doing work for external what? Pressure. Because as for the relation I write dq equals to cv dt, but dq is also equals to du, as we have learned already. dq equals to du also, because this is true for constant volume. See, this is for constant what? Volume. Because in constant volume, whatever heat supplied to the gas is used to increase the internal energy of gas. So the temperature raised by 1 degree Celsius without doing work done by the gas. No work is done by the gas. But the process just now as explained, the second case, where the heat which is supplied to the gas, which is equals to Cp dt, and this heat supplied to the gas is used to increase the internal energy of the gas, because to raise the temperature by 1 degree Celsius or 1 Kelvin. But at the same time, the gas even do some amount of work. Work is also done by the gas, okay, against the what? Pressure. That means this dq equals to du plus dw at what? Constant pressure. Constant what? Pressure. So children, one important part or conclusion I can draw from here is that the heat, okay, the heat that is supplied or given to the gas at constant pressure, the heat given to the gas or supplied to the gas at constant pressure to raise the temperature by 1 degree Celsius, okay, 1 degree what? Celsius, is greater than the heat given to the gas at constant volume. Because this heat is not only raise the temperature by 1 degree Celsius, okay, but this heat is also used to do some amount of work done by the gas against the pressure when pressure remains constant. Whereas the heat which is supplied to the gas when the pressure remains constant is only used to increase the internal energy of gas. That means to raise the temperature of gas by 1 degree Celsius. Okay, which means the difference of Cp and Cb, the difference of what? The Cp and Cb, okay, is equals to the heat used up in doing work against the external pressure. When the temperature of 1 mole of the gas is raised by say 1 degree Celsius only, okay, at constant pressure, which means Cp and Cb are not exactly equals to each other. So there is a difference between Cp and Cb, and as you know the relation is concerned Cp minus Cb equals to R. Because of this relation also I can say that Cp is greater than Cb. But the actual reason, as I said, why Cp is greater than Cb is because the heat supplied to the gas at constant pressure will be more than the heat supply at the gas at constant volume. Because at constant pressure, the heat which is supplied to the gas is used not only to increase the internal energy of the gas, to increase the temperature by 1 degree Celsius or 1 Kelvin, but that heat is also has to be used to do some work done by the gas against the pressure. So this is the main reason that Cp is greater than Cb. Okay, now I have explained in detail about the theory part of this chapter, isothermal and adiabatic processes. Now in the next YouTube video, we will solve some numericals.